Let's solve this managerial economics question together. So we have this particular question on demand estimation. So I'm going to read it so that we solve it together. So the question says that Papa's Pizza has been in the pizza business for a while. Though it has a large customer base, it seeks to be a market leader in the pizza market by increasing its customer base. This will mean that the firm has to set a price that focuses on maximizing its sales than to maximize profits. To help the firm decide on its pricing decision, it engaged the services of a research firm to estimate the demand for pizza. From a market survey conducted by the research firm, the estimated demand equation is, so this is the demand equation you've been given. So 240 minus 2px plus 0.4pz plus 0.08. So this is the demand equation for Papa's Pizza, the one they've given to you. And you were told that the values in brackets are the error terms in the question. So when you read down, they said the values in parentheses and are the respective error terms. So these ones are the respective error terms. And I told you in a previous video that they don't even need to tell you. Once you see the values in brackets, just know that they are the error terms. So 0.669 is the error term for 240. 0.6 is the error term for negative 2px. So the ones below them, they are the error terms for each of them. Do you get it? All right. So now let's move on to the I. So you're also given the values for some of them. So you're given the values for P, Z, and Y. They told you in the question that PX is for the price of Papa's Pizza. So anywhere you see PX, just know that is the price of Papa's Pizza. Then they also told you that PZ is the price of Eddie's Pizza. So that is what is here. Then they told you that Y is the disposable income. In the question, they didn't give you the price of Papa's Pizza, but they gave you the price of Eddie's Pizza to be 100 cedis. And they also gave you the disposable income to be 1,000 cedis as well. All right, so now that we know all this information, let's start with the I. So for the I, we are asked to interpret the coefficients of the independent variables. All right, so we are asked to interpret the coefficients of the independent variables. In the previous video, I explained this, but then I'm going to explain it again. So I said for the independent variables, you look at all the variables in the question. Do you get it? So you have px, pz, and y, the ones after the equal to sign. So px, pz, and y. Then look at the numbers that are attached to them. You get it? So let's start with px. The number attached to it is -2. So we are starting with the first one, which is -2 px. Do you get it? And they told you that px was the price of Papa's Pizza. So now let's interpret it. You let me write all the independent variables, then we interpret all of them. So you have -2 px, and this one you have 0.4. So 0.4 pz. Then the last one, let me write it down. So 0.4 pz. Then the last one is here, 0.08y. So now this is what you are about to interpret. And I told you that for this one, all of them just start with an increase. You get it? So an increase in, so let's start with the -2 px. You are going to see an increase in, just start with that one. I'm making it simple for you. This one to just start with an increase in, then this one to 0.08y, start with an increase in. So now that you know this, so just put in your head, anytime you're asked to interpret the coefficients of the independent variables, all of them just start with an increase in, that's all. So now, if written there an increase in, so now go to each of them, px. So you are going to interpret the px. So what is px? They say px is the price of Papa's Pizza. So we see an increase in price of Papa's Pizza. Then this one too is PZ. PZ is what? Eddie's Pizza. So an increase in price of Eddie's Pizza. Then Y is what? Disposable income. So an increase in disposable income. So I'm just making it easy for you so you'll be able to do it. Do you get it? So this one we are talking about 1 unit. So when you increase it by 1 or by 1 unit, so you can just say by 1 unit for each of them, by 1 unit. This one's an increase in price of Eddie's Pizza by 1 unit. Then this one too, by 1 unit. So now you've spoken about each of them. Now for all of them, now that you've written that an increase in price of Papa's Pizza by 1 unit, then now you are going to say it leads to So if it's negative, it leads to a decrease. If it's positive, it leads to an increase. I repeat, if you have something like negative 2px, then it shows that it leads to a decrease. You get it? But if it's positive, it leads to an increase. So now this one is negative 2. So it leads to a decrease in quantity demanded by negative 2. You get it? So an increase in price of Papa's Pizza by 1 unit leads to a decrease in quantity demanded. Then by whatever is attached to this one, so by 2 units. You get it? Because it's negative, that's why it's a decrease. Then an increase in price of Eddie's Pizza by 1 unit. This one, too, because it's positive, we'll say it leads to an increase. Leads to an increase in also quantity demanded by 0.4. You get whatever is attached to the variable. Then this one, to an increase in disposable income by 1 unit leads to an increase, because it's also positive, 0.08. So leads to an increase in quantity demanded by 0.08. So all of them lead to either an increase or decrease in quantity demanded. You get it? So quantity demanded will come last, then whatever they are talking about will come first. So don't forget. All right, so now we are done with the I. Let's move on to the II. So let me clean the board so that we do it together. Now let's go to the II. The II says that what is or are the significant determinants of quantity demanded, and explain. So they're asking you between this or the three of them, which one is significant or which one is not significant. In other words, which one actually affects the quantity demanded. It could be that the price of Papa's Pizza doesn't really affect it. Do you get it? It could be that the price of Eddie's Pizza doesn't really affect it. So we want to know the ones that actually affect it. If it actually affects it, it means that it is significant. If it doesn't affect it, then it's not significant. You get it? So now, in doing this, we can just draw a table for it. In the previous video, I explained all the steps, but then since you understand it, we will just draw a table for it. So now, that's for II. So the table, the first thing we have is our variable. So our variable. So we have px, pz, and y. So px, pz, and y. Then the next thing we are going to have is our coefficients. So the coefficients are whatever is attached to the variables. You get it? So px, whatever was attached to it was -2. Then pz, it was 0.4 that was attached to it. Then y was 0.08, so 0.08. Then the next one would add is the standard error. So please look at how I'm doing it. You're going to do the same thing. Do you get it? So how I'm doing, just follow the same. Next one is the standard error. I'll make it SE, showing that is the standard error. So I told you that the standard error is whatever is below each of them. Do you get it? So for -2 PS, the standard error was 0.68. Then 0.4 PZ, the standard error was 0.1. Then 0.08, the standard error was 0.025. So after that, we now find our T value or our T cal. So you can make it T, then you bring a CAL here. You get it? And the formula for it in the previous video, I'm sure you remember. So that's the coefficient over the standard error. So coefficient over the standard error. You get it? So this over this over this, and this over this. So -2 over 0.68. Then here to 0.4 over 0.1. So 0.4 over 0.1. Then here to 0.08 over 0.025. 0.08 over 0.025. So it's equal to. So -2 over 0.68 should give you -2.94, but we'll only take the positive. So you take the absolute value of it, which is 2.94. Then this one to 0.4 over 0.1 should give you +4. Then 0.08 over 0.025 should give us 3.2. You get it? So now that you've found your values, then you now make a decision. Now, usually they are supposed to give you a T value or your T critical. You get it? But then they didn't give it to you. Now, if they don't give you the T value, then you assume that it is 2. You get it? So this one, I don't think they give it to you. So because they didn't give it to you, that's why we are going to assume that it's 2. So now that we assume that our t value is 2, so our t or t critical is 2. Now whatever you calculate for, if it is greater than 2, this one like this, we got 2.94. Because 2.94 is greater than 2, we'll say that it is significant. So since this one is greater than 2, then it is significant. This one to 4 is also greater than 2. So we'll say it is significant, or it is statistically significant, so significant. Then 3.2 is also greater than 2. So it is also significant. They are all greater than 2. That's why we are saying that it is significant. Assuming they were less than 2, we would say that it is not significant. You get it? But because they are all greater than 2. Alright, so that's it for the II. So if you're asked to state which one is significant or not significant, this is how you go about it. In the previous video, I went deeper into it. So in case you don't understand it, if you want to know the steps and all that, you can go through that video. Alright, so now the II were asked to state the law of demand and explain how the estimated demand equation confirms or rejects the law of demand. All right, so they're asking us if this equation rejects or confirms the law of demand. And I think I also explained that in the previous video. So now what is the law of demand? The law of demand says that all other things being equal, the higher the price of the commodity, the lower the quantity demanded, and vice versa too. So also the lower the price of the commodity, the higher the quantity demanded. So what this means is that price and quantity demanded have an inverse relationship or a negative relationship. So if quantity demanded is positive, the price of X or the price of that same commodity should be negative. You get it? So quantity demanded is always positive at this side. So it means that the price for X should always be negative, or the coefficient for the price of X should always be negative. So this is the price of X, and you realize that it is negative, meaning that they have an inverse relationship, a negative relationship. So because of that, we'll see that it confirms the law of demand, or it accepts the law of demand. Assuming here was positive 2px, or it was any positive value, then we'll see that it rejects the law of demand. You get it? All right, so that's for the III. For that one, I don't need to write it. I'm sure you guys would be able to do that with the explanation I've given. All right, now let's go to the IVN. The IVN says that we should find an expression for quantity demanded in terms of price. Let me clean the board so that we solve it together. All right, so the IVN says that we should find an expression for quantity demanded in terms of price. Anytime you are asked to find an expression for quantity demanded in terms of price, it means that you have to make sure that price is there. You don't substitute the price. So if you are saying you find the quantity demanded, sorry, the expression for quantity demanded in terms of price, you are talking about the price of X. Do you get it? This is the expression for quantity demanded. So this is quantity demanded of X. So the price, you are talking about price of X. Do you get it? So we are saying that even if they're giving you the price of X, don't substitute it. Your answer should include PX or the price. Do you get it? These ones are other related commodities. Price of any speed. That's not what they give to you. This one is a related commodity. Do you get it? So the one you're talking about is PX, which is the one that they give us the demand equation for, which is QX. All right. So now what you are going to do is that you are just going to substitute the values for the other ones apart from the price of X. They didn't even give us the price of X. So just substitute the values for Eddie's Pizza and the disposable income into it. So we are going to get QX is equal to 240 minus 2px, then plus 0.4 pz. Our pz also, they give it to us as 100. So 0.4 into brackets 100 plus 0.08 into brackets y. Our y is what? 1000. So now I'm just going to simplify this. So our QX should give us 240 plus 0.4 times 100 plus 0.08 times 1000, then minus our 2px. So you can punch all this side on the calculator. 240 plus 0.4 times 100 plus 0.08 times 1000. And when you do that, you should be getting 360. You get it? Then minus our 2px. So we are done. So this is our expression for quantity demanded in terms of price. Do you get it? So this is the price that we are talking about, the px. All right, so you are done with the IVN. Now let's move on to the VIN. So the VIN, they are saying that we should use the new demand equation in IVN, which is this demand equation, to find the price and quantity that will maximize the firm's sales revenue. All right, so they're asking us to use this demand equation. So KOX is equal to 360 minus 2px. So let me clean the top part so that we solve it. So this is the new demand equation that they are talking about. So KOX is equal to 360 minus 2px. All right, so now I can clean this one. So now they're asking us to use the demand equation to find the price and that will maximize the firm's sales revenue. I didn't add the revenue. So let me just add the revenue here. So we know the formula for revenue, which is total revenue, price times quantity. Do you get it? So total revenue is price times quantity. And they're asking us for the price and quantity that will maximize this total revenue. Do you get it? So in doing that, we first have to find the total revenue function. So the total revenue is, as I said, the price. So that is our P times quantity. The quantity is what we have here. So 360 minus 2px. You get it? So our total revenue will be P times 360 will give us 360p, then minus 2p square x or px square. You get it? Because now the p is 2. You get it? So this part will be square. All right. So now that you're asked to find for the price equation that will maximize, anytime you hear maximize, just put to your head that you're about to differentiate. Because when you have a function and ask for the maximum, know that you're about to differentiate. Then after you equate it to 0. So we are going to differentiate the TR or this particular equation. So when we differentiate TR is equal to 360p minus 2px square, we should get the TR over the P and it's equal to, so 360p, when we differentiate it, we'll get only 360 with respect to P. So the P will vanish. Then minus 2px squared. So 2 will multiply negative 2. Then you get negative 4 px. The 2 will reduce by 1, so px exponent 1 is the same thing. Then now you equate it to 0. Do you get it? So now you are going to get 360 is equal to negative 4px will cross the equal to sign. Then get 4px. You can divide both sides by 4 to let px stand alone. Then our px should be equal to 90, right? So this is the price that will maximize the firm's total revenue. But now we also need to find for the quantity. Do you get it? So we'll substitute this price into the quantity, the KOX, which is 360 minus 2px. So I'm going to substitute it into this. So let me do it here. So you are going to get KOX is equal to 360 minus 2px. And our px is now 90, so minus 10 to bracket 90. And this should give us 180, right? KOX is equal to 180, right? So the price and the quantity that will maximize the firm's sales revenue will be 90. So 90 is for the price and 180 units for the quantity. Do you get it? All right. So we are done with the VIN. Now let's move on to the last one, which is the VIN-I. So the VIN-I says that labor expects employers to increase disposable income by 20% in the next year. How will this increase in consumers' disposable income affect the quantity demanded? All right, so let's do it here. Our previous income was 1,000, right? And now they're saying it's going to increase by 20%. So if 1,000 increases by 20%, so we have to first find for 20. So this is for VIN-I, right? So VIN-I. So 20%, let me just write the answer. So we have 20% of 1,000, and that should give us 200, right? If I'm not mistaken. 0 cancels 0, 0 cancels 0. So that will give us 200. All right. So now it means that income increases by 200 from 1,000, and it increases by 200. So our new income is 1,200. You get it? So now we are going to substitute all the values back into the demand equation. Do you get it? So we are going to get KOX is equal to 240 minus 2px plus 0.4 pz. Our pz, nothing will change to it. So the pz will still be 100. Then plus 0.08. The y is for our income, and now it has increased to 1,200. So it's no more 1,000 like first, it's now 1,200. So 0.08 is 1,200. So when you solve this 240 plus 0.4 times 100 plus 0.08 times 1200. I think you should be getting 376, right? So 376, then minus the 2px. You get it. So even from this, our old demand equation, we got 360 minus 2px. When we substituted the old 1000, and after we substituted the 1200, which is after income had increased by 20%, we got 376 minus 2px. So you realize that for this side, the negative 2px is the same, so the price is still the same. But then for this side, the 360 moves from 360 to 376, so it increases by 16. You get it? So you can see that when income increases by 20%, demand increases by 16 units. That's all. You can just say that simply. You can also decide to find for the change, and you'd get the same answer. But then since it's moving from 360 to 376, you can just say quantity demanded increases by 16 units after income increases by 20%. Do you get it? Alright, so we are done with this particular question, which is our question 1. In the next video, we are going to look at question 2. Thank you very much for watching this video, and I'll see you in the next video.